So today we are going to talk about the vertical mill, and we're going to do a demo on the vertical mill. I'll show you how to use it safely, but when I do that, we're actually going to make a part, all right? And after this brief explanation about some tooling for the vertical mill, some other things, we're going to go out to the shop, and the rest of the video will be in the shop. We're going to run by the lathe and look at the print because that's the tool. We're going to make a tool for the lathe, sorry. And I'll show you that before we get started, and then we'll go over the print, and then we're going to go over to the mill, the vertical mill, and we're going to look to see how to use it, and we're going to make a part. Alright, so unfortunately this is where the videos start to get a little bit longer because we're gonna be making stuff. In the future, alright, when I'm cutting and stuff, I'm going to fast forward the video. I'll still leave it there, it'll just be in like 10 times speed. But in the beginning, I'm not going to do that, okay, I don't think. I'll see how it goes when I edit it, but I want you to know that I'm not just gonna, I'm not stupid, okay? Like, I realize, okay, and I know you guys are watching in 2 times. I know all that stuff. All right? But in the future, I will, when I edit the video, I will make things go faster, okay? So it's not a lot of watching, but like I already said, in the beginning, you're gonna have to, I want you to see it cutting, okay? You really miss out if you skip around a lot. You are missing out, all right? Also, when in the introduction of the class, when I said you get to see things that I normally wouldn't show in regular lab, actually that's going to start today. So I'm going to do techniques on the mill that I probably wouldn't show you guys in regular lab setting, okay? But I'm going to present this class in real world, all right? So I'm going to tap today, okay? And I'm not going to do it like the absolute fundamental. I'm going to actually do it in the mill, all right? So that's one thing, and I'll explain more. So let's get going. In the vertical mill, we remember, like, we got, do I need to draw it? We got, the table, X, right, is this way. This is the table, and we got Y. Actually, remember, we got Y going back and forth, and of course we got Z going up and down, and that's our spindle, right? Okay, remember that? We're going to see all that today. What can we put in the spindle is what I want to talk about. And what I've got here are some end mills, all right? And you saw briefly that the other day. I'm holding 3 in my hand right now, okay? And I want to talk about them. This is a 2-flute high-speed steel end mill. Okay, so it has 2 flutes. All right, and unlike a drill bit, remember the end mill actually cuts on the side. So these flutes are sharp, very sharp, and will cut you. So will a drill bit, all right, but not, these are designed to cut. The drill bit is not designed to cut. They come in a variety of different flutes, number of flutes, and different end profiles, okay? And I want to talk about that right now. And these 2 actually, these are solid carbide. I'm just throwing that out there, I know, and I'll talk about carbide tooling later. So I want to just draw these 3 profiles on the board really quick, because they're the most popular types of end mills. End mills come in all shapes and sizes, just like everything in machine shop, right? I mean, all different profiles, but these are the most popular, okay? And we'll talk about their sizes, their diameters as well too. All right. So, okay. Number 1, This is an end mill. Some people call it a square end. That's fine. There's nothing wrong with that, okay? But typically it's a square, or typically it's an end mill, all right? And the profile of it has a sharp corner. So here's another 2-flute high-speed steel end mill, okay? Just regular old square tip, okay? Here's a 3-flute. Yes, I'll get to why we use different flutes and etc. in a minute, okay? The next most popular style of end mill is called there's 2 terms for it, but you can call it a ball end mill. The other term would be spherical. Okay? So I think in McMaster-Carr, if you go to McMaster-Carr's website, they call them sphericals, but they also are known as ball end mills. And this is a ball end mill. So we can see that it's like half a circle as opposed to being square. Okay? The next most popular, and I'm going to say these are very popular, all right? And I'll talk about what they do in a minute. But the next most popular is a end mill, right? This type of square end mill, only it has a radius corner. So it would be a radius corner like end mill. And their slang term is bull nose. I have no idea where that came from, all right? But what's going on here is this corner is radiused to any radius you want, all right? Here is one, and it looks to me like that has got a 1/8 inch radius on there. Okay, so you can see the corner's been rounded. This is a 2-flute radius corner end mill. All right. So those are the 3 most popular styles. Like I said, they come in all shapes and sizes. Okay. You can get them ground to any diameter you want. Okay, but most popular off the shelf is going to be in fractions, in 1/16. So it's going to, you'll get you guys, they go really, really, really tiny. Okay, but I'll just start at a 1/16. So it's going to go 1/16, right? The next most popular, well, 3/32. You can get that, okay, in 30 seconds. But you get my point, okay? 1/8. You'll be able to get 3/16, okay? Quarter, all right? What you're not going to see typically right off the shelf is, say, 225, right? You're not going to see that, okay? Just off the shelf. Can you get it? Yeah. You can get them ground to whatever diameter you want. Obviously, that's really close to, say, a quarter, okay, 225. Let's say a 1/4 inch end mill costs $20 or $25, okay? If you get one ground at 225 and they have to grind it, I'm making this up, it could be $50, all right? So don't do that, all right? Don't do that. Don't design parts for a special ground end mill, okay? To give you an example of what I got here, this is a 3/4 ball, okay? So the diameter is 3/4. Let's see, this is a 5/8 bull, radius corner. This is a 3/4 end mill. This is a 1/2. I've got some more here. Here is a 1/2 inch 4-flute end mill, okay? And this is a 5-flute 1/2 inch end mill, square corner. Fancy. Okay. Here's the guidelines, and by no means is it always this way, okay? But here is the guidelines. All right. So two flute. Two flute is your general all-purpose end mill, okay? It will cut anything. It'll cut anything. It will cut steel, aluminum, it'll cut titanium. It'll cut anything, okay? Plastic, it will cut wood, although the finish isn't quite desirable. Yeah, so this two flute, and it's available ball, whichever way you want it, is your general all-purpose end. The three flute, and you guys, like I already said, this is not concrete, okay? This is just like a guideline, okay? So typically, three flutes are for aluminum. Okay? Four flutes are for steel. That includes stainless steel too. All right. The five flute, this is kind of debatable. I shouldn't even put this up there. It's really for finishing and maybe like really tough metals like Inconel, etc. Titanium, stainless steel. Okay, but it really, I think, and I actually I could be mistaken about that. It's for finishing. I rarely use a five flute. Okay, very rarely do I use it. I use these three flutes all the time. Really depends on what I'm doing. I do have a lot. We do a lot of parts here in aluminum at school, especially in the automated machines, the CNC machines. So I've collected quite a bit of three flute solid carbide just for that. Okay. Now let's talk about those profiles. Okay, that's what the flutes are for. All right. So this is tough, actually. Students have a hard time with this one sometimes in the beginning. Okay. This is round. Okay? So if we look at a part, top view, and we want to put what's called a pocket in here. Okay? And if we look at it, this is top view. If we look at the front view, and it's a pocket, like a blind hole kind of, only it's not a hole anymore, it's a pocket. So here is our, for those of you who don't know, dotted lines in drawings are what are called hidden lines, okay? And this is the top view. If I look at it from the front and I want to see what's inside, which normally you couldn't see, in mechanical drawing, we represent that with with a dotted line in there called hidden lines, okay? Very often throughout the year, especially at the end of the year, I get parts not only from students, but from faculty too. And they have a pocket with square corners. Now, a pocket, remember, it doesn't go all the way through. Okay? The way that I gotta cut that is with an end mill. So my end mill is gonna come around here. I'm gonna hog out this whole area with my end mill. Maybe I'll do a zigzag pattern and then come around, clean it up. Okay? See down here? This is the hidden line. Okay. The profile of the end mill is round. So I can't when I come around here, I'm going to end up with a radiused corner. It's not impossible, but it's extremely difficult to get a corner in a pocket square because the end mill is round. Do you see that? Okay. Now remember, the end mill profile at the tip of it's square, so I can have a square corner on the bottom. So what's on the bottom can be a nice square corner. Okay. But on the side, in the corner here, is round. All right? Okay. So it's really important. So if I have a 3/4 inch end mill, what radius am I going to end up with in the corner? What's half of 3/4? So if I have a 3/4 diameter end mill, I'm going to end up with a 3/8 radius. Okay? So if I wanted a 1/4 inch radius, if the part called for a radius of a 1/4 inch, what size end mill do I need to use for that corner? Half. If they said 1/8, I'm going to need to use a 1/4 inch end mill. Okay? Okay. All right. Let's look at another part. Let's say this is my part, and I'm making this up, right? And I'm going to bolt this. Those are through holes. So that's the front view. Blake. Come on, dude. Use your head. Watch this. I am going to teach you guys how to see differently. So there's the top view, and here's the front view. And this part has holes in it. All right? So if I were to draw the right view, some of you are like, dude, and you know what? I'm teaching you something without you even knowing it right now. There are the 4 holes that I just this. So this is the top view. This is top, front, right. Okay? Now, let's say this started with a piece of a giant chunk of metal. I could take this end mill and remove all this material, okay? And because all this material in here, okay? And because this end mill is square corner, right? I could end up with a square corner down here, okay? But this part, because of the holes in it, all right? Check me out, really. Is mounted to, say, a wall. And we're going to apply some sort of force out here. Okay? I don't know. I'm making it up, right? Maybe we're going to put a 5-gallon bucket of water on this thing. This corner here is a weak spot. All right, I'm going to keep the jargon really simple. It's going to develop stress fractures, things like that, okay? So a lot of times in engineering, what we do to relieve that is we put in a radius corner, also might be known to some as a fillet, okay? And the way that we can generate that fillet, so it's not a square corner, it's nice and round and a lot stronger. Guess what? Some of you are on it, right? Is with this ball end mill. So now this ball end mill will create that fillet, okay? So there's two examples, and then I want to show you one other example. What could we want a radius corner end mill for? Okay. Well, one example. My black pen's dying, so I'm going to move to blue. One example. There's two examples actually. Number one, an O-ring channel. Yeah. So let's say we had a part that needed an O-ring, like a seal, okay? And we wanted the bottom of it to have a radiused corner in it. Okay, not just a square corner from the end mill. Okay? That's one example of the radius corner end mill. Okay? Another example, well, I didn't draw that all the way, right? So we might run the end mill through here to put a seal in or something. A piece of rubber, like an O-ring. Another example might be, we have a round shaft. My buddy Dan just did this the other day. He's like, hey Blake, you got a radius corner end mill? I said, sure do. Can I use it? I said, yeah. So this is round. And it's round, just like a shaft. And what he did was he wanted to turn this square, the end of it square, okay? So that profile would look like, if you looked at it from the right view, it's going to look like that. And what he did was he put in a radiused corner, okay, and made this end of it square. To put like he wanted to be able to turn the shaft with a lever, okay? And so he made these square and then was able to mount on his lever, right, to turn the shaft on something square, okay? And we don't want a square corner in here for reasons I already described. It's weak. That corner makes the shaft weak. All right, we want to have a nice radius. So that's another great example for the radius corner end mill. All right. I know I've said it 1,000 times. This stuff goes on and on. We could do this the rest of our lives. All right, the rest of our lives. Not even like a full year, 2-semester class. The rest of our lives. Okay? That's why it's so awesome. That's why you never stop learning. It's just incredible. Okay? This is the very basics. We're going to go out in a minute, but there's one other tool that I want to show you that we can put in the end mill, that we can put in the vertical mill. And this guy here, you can see there's the cutter right here. This is called a fly cutter, okay? And as it, put it in the spindle, and it spins fast. We're going to use it today, okay? But it is not really for removing a lot of material. That's what the end mill's for. What the fly cutter's for, it's called a fly cutter, and it's for a nice finished surface. Okay. So I don't know if there's any of you that are really into cars and like rebuilding engines and stuff, but when you go get your cylinder heads surfaced, or get your block decked, jargon, they they use a fly cutter, or in the past, not so much anymore, but they still do. They use a fly cutter to clean the mating surface of your cylinder head. They'll use a fly cutter to what's called deck or surface your engine block, where the cylinder head and the engine block meet, okay? And they're only gonna be removing about 10/1000ths of an inch, all right? Okay, so that's it for in here. Let's go out to the shop, and I'm just gonna, so the way that this rolls, in case you're wondering, is some of the time I'm gonna have the camera on my head, and I don't like it because I feel like a dork, but I have the camera on my head. Other times I have it in the tripod, and whatever works for the shot. And as I'm making this stuff, I'm just talking, okay? And so let's go look at what we're gonna make. And actually, I forgot, I have it right here. Let's go look at what we're gonna make, and then we are going to go to the mill, all right? This is what we're making. This is a dial indicator. We're gonna talk about dial indicators either next week or the following week, measuring devices, okay? And see this aluminum block right here? This is what we're making on the mill. So it's a rectangle with a slot in it, okay? And it has 2 tapped holes. One of the holes mounts this indicator, okay? This dial indicator. You can see every tick on there is 1/1000th of an inch, okay? And then this screw right here, this thumb screw right here, this, which I'm going to show you right now, locks it to the lathe, all right? Now, before I even pull up the print, which I have emailed to you, I'm going to show you how it works. By the way, so all the parts that we make for the week, I will attach a PDF drawing. Okay, I did that in the past, and a lot of students loved it. They even printed it and watched as we're making it. We're really able to follow along. I don't want to go on a lecture rant. I want to get this stuff done. But being able to communicate what's in your mind to the machinist, all right, is like, whoo, so important, okay? And a lot of times the way that's done, or most of the time the way that's done, is through a drawing, okay? That's why I spend time to write the front and front view, the top view, the right view in the right sequence and things like that, okay? This is not a mechanical drawing class, but I will touch on it periodically, all right? So let's go to the shop. So, all right, so here we are at the lathe, and this, remember the carriage moves? Remember I showed you that? Remember we're gonna move the carriage and it moves back and forth? Well, that's what this tool is for. This is to measure how far I move the carriage when I cut, all right? And the way that it works is this slot right here mounts onto, these are called ways, not important right now. Ooh, that's got a chip in it. And it mounts on here, and then this thumb screw locks it in place. Okay, now it won't move, right? Okay, and then when this side of the carriage touches the dial indicator tip, we can see how much we're moving, all right? And so some of you might be going, well, why are we making one when there's one right there? Well, let me show you why. Because I just refurbished this lathe. I just refurbished this lathe, remember, for us this semester, and lo and behold, because this lathe is a little bit bigger, my device that I made this, by the way, doesn't fit onto this, so I have to make a new one, and it'll be just for this lathe forever, okay? So that's what we're making. I'll just put this aside, and let's go take a look at the print, all right? All right, so here's everything we need for this project, aside from the machine, okay? Here's a piece of scrap aluminum that I found. It's just under an inch. Don't worry, I'm gonna explain all this stuff, okay? like the dial indicator that I just showed you. I've got one right. These are the dial indicator that I showed you that gets mounted onto here. Okay, I'm going to explain all that to you, but I found an interesting way of teaching this stuff, and that's to kind of just slowly introduce things. That way, when we actually do talk about it, it's not just a shock. These are called dial calipers, and I don't even want you to worry about it, okay? I'm going to talk about them, but you're going to see me use them, and then I'm going to talk about them, and just trust me. Okay, now here's our print. Now, if we look at our print, it's actually pretty simple. Here's the front view, here's the top view, and here's the right view. And what we see here, and of course the dotted lines, they're the hidden lines, okay? We see a bunch of really kind of nice numbers, okay? Like 0.750, that's 3/4, 375, that's 3/8, 3 inches. There we go, 5/16, 18, that's for this thumb screw, okay? And then the 1/4-20 is where this mounts with this 1/4-20 socket head screw, okay? Where the indicator mounts. We're basically making the same thing, just different size. But if we go look up here, it starts to get a little bit more interesting. 1.950 can be minus 3 thousandths plus 0. What does that mean? That means that this slot, okay, top view, right? And those are the hidden lines. This slot, I would like it to be 1.950 to, come on, 947. So it can be anywhere in there, okay? I don't want it to be tighter than that, and I don't want it to be looser than that. And this is why, okay? Let's go over here. If we look here, dang. If we look here, and I measure these, okay? I know the glare. We can see that this is 1.94, roughly. 194, all right? I want it to fit over it loosely. So it can be 195, okay? I want it to just slide right on there, nice and loose. That's why that's dimensions are that. Okay. So what I'm gonna do first is I'm gonna take my piece of aluminum here, and I have a scale. It's not a ruler, it's a scale. And all this is all funky, all right? And then it's too big. So we need a piece that's 2 1/4, 2.25 by 3, rectangle. Well, this is already 3, okay? So, and you know what? It's gonna be just fine, just the way that it is. I don't need to necessarily machine any of this. I might clean it up a little bit. Well, who knows? I'll do that on the fly. So it's like this, okay? So I need, right? I need 2 1/4. So what I'm gonna do is I have a Sharpie here, and I'm going to mark off, just say 2 1/4 with a Sharpie. Yeah, totally not exact at all. Here's my square. All right, boom. All right. Now, what am I going to do next? I'm going to cut this on the bandsaw. All right. I got that piece of material out, that aluminum out of there. I'm going to clean out the jaws with a rag. All right. You saw me do this last week. And here's my part, 2 1/4. Okay. And then I have another piece of aluminum for the other side of the vise. All right. Okay. And
one technique that we do in the shop always is what's called leaving the line, okay? And that's why I wasn't so totally precise when I measured it. All I wanted was essentially just a reference of where 2 1/4 is, okay? So what I'm gonna do is I'm gonna bring the blade down close, all right? And I think you can see that. And I'm looking down in here, and what I'm gonna do is I'm gonna line the blade up just right up against, and I'm gonna leave the line. It's called leaving the line, okay? Now I go ahead and tighten the vise. It's pretty good. And go ahead and turn on the machine. And slowly lower the blade down onto the material, okay? All right, machine has stopped, auto shut off, and I can go ahead and take my material that I want to use out. There's scrap. After I cut this on the bandsaw, I got a lot of burrs here. So what I've got, and I keep next to all the machines, are a file. And you're going to see the files that I use throughout the semester, and don't know the right word, but I have a very good relationship with these. They're some of my favorite tools, okay? The simplest thing ever. Files they don't cut on the pull. I hadn't mentioned that, all right? They cut on the push, okay? And so what you don't want to do is this. Don't do that. Don't do that. Just cut, just nice and easy. This is how I hold a file. You can hold it like this, okay? But I think you get a lot more control this way, okay? And what I'm doing is I'm just deburring this. I'm just knocking off the burrs, okay? And, okay, looks like I just got this one. All right. Okay. So, this is ready to go in the mill, okay? To start machining our part. All right. Let's go over the mill though, real quick, okay? So here we are, and at the vertical mill, and we talked about this briefly. Let me turn it on so I can get everything working. Now, first thing I want to talk about is the spindle, okay? Now, all mills have a different way to lock in this tool. I showed you this already, but this has a lock up here, and that locks the spindle from moving. And now I can go ahead and undo this collet down here, and that's a drill chuck that I was able to put into the machine, okay? And what I'm gonna do, as I know what tool I'm gonna be using, I am going to be using this 1/2 inch end mill, all right? So let's go ahead and put that in here. Yeah. Oops. So I got a 1/2 inch collet, and I'm gonna go ahead. Remember, we never put the collet or the chuck around the flutes, okay? And I'm just gonna snug this up, pull that pin out up there, okay? This is how I turn it on and off, so I can go right-handed. There's the brake, left-handed. But we're gonna be going right-handed, but I don't like that. Anyway, I'll get into that later. Okay, so that's the brake. This is how we can move the spindle up and down. So this lever right here moves the spindle. Actually, it's the quill up and down. This is the quill lock. So if I lock it, I can't move it anymore. It's okay. I can't move it anymore. It's locked. So I unlock it, and I'm able to move the quill up and down like a drill press. This, I'm gonna raise the table, okay? I'm gonna do it with the power feeds. The machine has power feeds, which I will explain right now. But it's higher now, so we're gonna be able to see a little better. All right. This wheel moves the table along Y, okay? So away from me. Sorry, take off my sweatshirt, I'm hot. And so this handle here, see the table moving? Back and forth on Y. This moves the table on X. This moves the table up and down on Z. Okay, so I can turn this handle, all right? So, see that, right? And turn this handle and move the table up and down. Now, most vertical, not all, but most vertical mills have a power feed, some sort of power feed on them, okay? Some just have it on X, some have it on X and Y, and some have it on Z as well. I am fortunate that I have, on this mill, I have X, Y, and Z. And this mill is hydraulic. I'm not even gonna get into it. It's not electric power feeds. It's hydraulic power feeds, means it's controlled with oil, okay? I'm not gonna talk about it, but I am gonna demonstrate right now the power feed function, all right? So if I turn the mill on, I can take this handle, put the handle this way, and the table's gonna move that way. Ready? It's slow right now. Let me speed it up. So if I speed it up, now we're moving, okay? That's my feed rate. If I move the handle this way, okay, the table's going this direction. I have one for Y too, and that's right here. So if I move the handle that way, the table's gonna move that way. See the wheel spinning automatically? Okay? If I pull the lever this way, the table's coming towards me, okay? And guess what? I have one for Z too. Here's the lever for Z. Now the table's moving down. See the wheel spinning? Okay? If I move the lever up, the table's gonna move up. Now it's moving up. All right. Before I get into the actual dials, okay, there's one more lever on here that I want to talk about, and it's called rapid. So I adjusted the feed rate, how fast it's moving, by this handle here, okay? You're not gonna see this very often. Actually, you probably won't ever see this except for this class. So I'm not even gonna talk about it, okay? You're gonna see a different type of mechanism. You're not gonna see this type, all right? I will tell you that it's pretty awesome, but you're not gonna see this. So I'm not gonna really get that into it. Yes, there are numbers, okay? So, but I'm not gonna get into it. But I am gonna show you the rapid function because I use it all the time. So if you noticed that if I move X this way, nothing's happening. That's because the machine's not on, all right? So it's a safety feature they built into the machine. The tool, the motor, the spindle needs to be on for me to move the power feed. Now, I can rapid though. Rapid means I'm gonna move the power feed as fast as the machine can do it. And by engaging it and lifting this rapid lever right here, this lever, it's gonna move fast. See that? Oop. Okay, and that's how I move the table up and down real fast when we first started, okay? So now I'm moving up, but I gotta pay really close attention, okay? If I run the vise into the tool, major damage is gonna happen. That is called a crash, okay? Crashes can happen on any type of machine, whether it be a drill press, a lathe, or the vertical, any type of machine. So it's very important that I pay attention. So I'm gonna move Y towards me, okay? With the rapid there, okay? All right? Notice that it won't work unless I have the machine on. Now the power feed's working that way. All right? So, I know there's lots of levers here, but guess what? It just got real simple. And it's the same with the lathe too. Oh, ignore this. This is power feed for the quill. I rarely ever use it, okay? Once in a while, very rarely. There are more features to the vertical mill, but I'm not gonna really get that into it, okay? Because you don't use them very often, and if you were to be getting into those features, it'd be much more advanced machine shop class. So maybe we'll have to use some of them, maybe we won't. I don't know. We'll cross that bridge when we get there. The important part is the fundamentals. The only thing that I didn't show you yet is how to adjust the spindle speed. And I always say that for last anyway. So every machine is different, okay? And before you go adjusting the spindle speed on the machine, you really need to know how the machine operates. This particular machine has a variable speed up top there, okay? This is how you adjust the spindle speed. However, I need to adjust the speed with the machine on, okay? Some machines you adjust with the machine off. This particular one has got to be on, all right? So when I turn it on, I'm able to turn this and either speed it up or slow it down, okay? Okay? I also have a gear switch right here. Just make sure you can see that. Yeah, right here. I got high, neutral, that's obvious, so it's not engaged, and low, all right? So if I put it into low, it's gonna just turn significantly slower. We are gonna be using low later, so I will show you that. Excuse me. All right, there you have it, okay? That's it, all right? On the wheels, if you look here, each tick is the thousandths place. So we know what that is now. So if I move this, all right, if I go from 130, 130 thousandths to 140, 140 thousandths, I move the table 10 thousandths, 0.01. Each little tick is 1 thousandths of an inch. There, I just moved the table 1 thou. Okay? 0.001. This particular dial, I believe, is a 1/4 inch dial. Yes, it is. So you can see that I go from 240 thousandths, which we're at right now, to 0. So 240 plus 10 thousandths, taking it to 0, is 250 thousandths. All right? One time around on this wheel is a 1/4 inch. Okay, or 250 thousandths. The Y wheel is the same way, okay? However, the Z wheel on this machine is on an 1/8 scale, okay? So 125. Now, I know I'm not writing this on the board. This is actually kind of rare. Most machines, these are all 100 thou increments, okay? Most machines are 100 thou. All right, moving on.
All right, so before we get started on our part, we're gonna have to do something here, and that is we are going to have to true this block up, okay? It's not square, meaning like, don't worry, I'm gonna get to all this, but it's not trued up, it's not square, okay? We need to do that. And the way that I'm gonna do this is pretty textbook. In the future from now, I probably won't go so textbook. There's some tricks and like some shortcuts, okay? But for the first time, I'm going to do this textbook. Now, there's a couple things I need to go over. Okay, first of all, in the machine shop, on the mill, especially with a vise, okay, we need to rest our material on top of these hardened ground metal. They're called parallels, and they're hardened steel, and they've been ground very flat. I'm not going to say they're perfect, okay, but they're pretty flat, and they come in pairs, okay. The other thing we need to go over real quick is the vise. All right, so I'm going to move these off to the side. If you notice, of course, that the vise, this, right, this part of the vise moves back and forth, okay, to clamp the material. This part of the vise is stationary, okay. So what's happening here is the vise, the back of the vise, is set up, parallel to the cutting tool. All right. So if you were to imagine, one of those end mills in the spindle, the back of the vise is as parallel as we can get it. All right. And I've already done that. We'll go over that later. But I've already done that. But really important, the back of the vise is our reference. So everything is registered, okay, if you will, off the back of the vise. So what I'm going to do is I'm going to put two parallels in here, okay? And then I'm just going to put this in here. So I'm going to do it this way. And then what I'm going to do is I'm going to use this aluminum welding rod. And I'm going to put it at the front, okay, of the vise. And the reason that I'm doing that is because if I have these two flat surfaces, when I close the vise, I don't know if this surface ran up against this flat or if that surface ran up the back flat. What I want is whatever flat surface I machined to run up against the back of the vise, all right? Because that's my reference, and that's where I register from. So by putting a metal rod in here, a round metal rod specifically, I can somewhat ensure that I just, there's like there's something round pushing up against it, right? Okay, so it's gonna it's not gonna cock it. It's gonna push whatever that flat up against that flat. Because this is round against a flat. I know. Okay, and then what I'm going to do is I'm going to use a dead blow hammer here, and I'm going to tap as I tighten. I'm going to tap this block in, and what I want to see is that these parallels don't move. So that one's kind of shifting on me. Okay, so it's just be easier if I got it out of the way. All right, there we go, okay? So now I know, all right, that my flat surface, it's not flat yet, but this bottom is making contact with these parallels, right? And it's not moving. And I also know that this back face back here is flat up against the vise, all right? So now we can go ahead and make our first cut. And I'm going to use the fly cutter, and I'm going to surface this top. All right, so here's the fly cutter. Go ahead and put that in. All right, put this in. Okay, and now I'm going to turn the mill on And it gets loud, I know, I'm sorry. And I'm gonna surface this, okay? Alright, so what I'm gonna do, bring this down. Just close, okay? And lift the table up a little. Alright, remember, we never start with the tool touching the surface. So I'm going to back this off, move off X, whoops, get this sort of centered on here. It doesn't have to be perfectly centered on here, just sort of eyeball it, alright? Oh, I'm in neutral. Alright, so go. Come on, there. Alright. And I'm going to run the fly cutter at around 1,000 RPM. Maybe a little less. Alright? And bring this over. And now slowly, very slowly, raise the table until I just touch. It's called a touch off. There, I just touched, right? Now I'm going to back this off, and I'm going to raise the table, I don't know, around 10,000, okay? Okay? And now I'm going to, this is my feed rate, right? I'm going to slowly come around here. Chips are coming towards me. Alright. So I'm just gonna, I don't need to, but just for the purpose of demonstration, I'm gonna do it again. So I'm gonna take about, I don't know, 10 or 15 thousandths here. Okay, there's 15. And I'm gonna do it again, just so you can see. Now the chips will go that way. Yes, I could use the power feed, but I'm not going to yet. I'm going to do this all manually. Is I'm going to take it out, alright? My rod. And now I have burrs all over the place. I need to remove those. So just knock these burrs off of here with a file. It could have been a little better, but that's okay. Alright. So, anytime you take your part out, you have to make sure you clean the vise out. Because you don't want any chips in there, okay? No chips. They'll ruin your setup. Okay. So now what I'm going to do, it was like this. Normally I'm going to not do it the right way the first, don't worry, just don't worry. Okay, I'm going to flip it over. I've got a long rectangle here, so I gotta do it a different way, Sam. And I'm going to pop this down, and you can see now it's not sitting right, okay? Let's see about now. Okay, so see, machining is about solving problems. So let's see here. Right here. I'll try this again. Make sure I don't have any burrs. What's happening is because the block isn't squared up, it is pushing it up and it's lifting it up like this in this parallel. And I want it to be flat. I want two parallel surfaces. So I'm actually going to try it really quick without the rod. And I'm still not getting good. So let's try this. And then I might have to go back to the textbook. All right. Let's see what I get here. There we go. I got it. So I know that it's flat. All right. And what I'm going to do, real important here, guys, is I'm going to lower the table because I don't want to start with the tool on touching the part. So I'll just raise the table up a little, get it close, back it off, okay? Turn it on, and we'll just take a couple passes. Bring the tool over. Slowly. Just very slow, just until I touch, alright? And then I'll go ahead and I'll take, like I like 10 or 15 thousandths. I'm going to use a power. Oh, that's real slow. Okay. There, speed it up. There we go. Keep that. Okay, so all the way off, my tool is off the part, and go ahead and raise the table about 15. Alright, and then we're off. So, now what I want to do, I'm going to take it out, and I want to see if I'm going to deburr here. Okay. All right. I'm going to take some calipers, and I want to see if I'm parallel. And the way I'm going to do that is I'm going to measure the corners here, and let's see where we're at here. So I can take a reading. It's I don't know, 918, 0.918, 918 thousandths along this edge. So let's see what we got here. 918. And 918. Okay, so by measuring the four corners and saying, oh, I've got 918 thousandths, I know that I've got pretty much, within good enough for right now, two parallel surfaces. Okay, so let's go ahead and take these out, and I'm going to grab a different size parallel here. Okay, it's another parallel. And I'm going to use this, and what I'm going to do, got to clean the vise out. So, put this in here, okay? What I'm going to do now is, now I've got two parallel surfaces, and if you look at it this way, I've got some weird trapezoid. Even though it looks like a rectangle, it's not, all right? and the square here will tell you that it's not. I mean, it's close. But I got a trapezoid, basically. What I want to do is I want to establish just one flat surface. And I don't care if the bottom's off or not, all right? So what I'm going to do is I'm going to lower the table and then bring the vise in here. Check this out. And all I'm going to do is put this in here without the rod. I don't need the rod anymore. Why don't I need the rod anymore right now? Because these two faces are parallel, right? So all I want to do is get this in here like this. All right? Now it's in, okay? And I'm going to machine this off. And what's going to happen is now these three sides, after I machine this off right here, they are going to be trued up to one another, okay? And now I can go ahead and I'm going to have all I'll have three sides that are trued up, all right? So let's go ahead and do that real quick. Move this over. Okay, once again, I'm going to raise the table to make it close. I'm just eyeballing it, all right? Turn the machine on, and now very slowly raise the table to just touch. Alright, I just touched, so I'll bring this off the table, okay, and I'll take like 10 or 15,000. So let's see what happens. See how much material we remove. Looking good. Yeah, the chips are coming at me. So I hope I don't need to say that when the machine's on, you keep your hands out of there, right? I mean, obviously. Don't go in and try and feel it. Wait till it's off. Alright. So, I want a nice finish, alright? I'm just that way. I like to, and it seems to be finishing better when I go this direction. So, I'm just gonna hit this real quick. I'm just gonna take a little bit, like 5 or 10. So turn the power feed off, turn the machine off, hit the brake, and I'm gonna take the part out. The file, deburr it. You gotta be careful, see all that? Those things are sharp. Okay. Notice how light I am, right? I'm letting the file do all the work. It's not me, it's the file. It's called technique. Alright. So, now, if everything went according to plan, when I use this square, I should have this side to this narrow side square and this side to this side square. Okay, so let's take a look. And yes, that looks good, and that looks good. All right, so guess what? I can go ahead now and make sure there's no chips in there. And now, if I rest the side that I just machined like that on the bottom of the parallels, when I go machine this side, right, I'm gonna have 4 sides that are spot on. Okay, so I got a trick for you though. What I'm gonna do, alright, is I'm gonna hang this off the side of the vise like that, so it hangs out like that. The reason I'm gonna do that is that I'll be able to take some calipers and get in here and measure, alright, without taking the part out. So, if we remember, the print says that I need to be 3 inches by 2 1/4, right? Okay? So this tells me that I've got roughly 110 thousandths left. Alright. So that's exactly what I'm going to do right now. Okay? I'm going to hang this off the side, and I'm going to put this in here. There, look at that. That's nice. And I got it hanging out the side of the vise. You know what? I'm going to do it this way so you can see better. I'm just used to doing it that way. Okay. Alright, let's check that. That's good. That's in there, okay? So take this out, right? I don't like to have my measuring devices on the table. So the hammer's okay, but, all right. So I'm gonna lower the table, and I'm gonna bring this over close. Okay. And same thing. All right. Now, here we go. Doing it again. Check this out, all right? Now, I'm not going to take the part out. That's real important. Don't take the part out at this point. What I want to do is get this down to finished dimension, which is 2 inches and 250 thousandths, or 2.250, all right? Now, if we notice that if I don't touch the table, if I don't move the table right now, or take my part out, my tool is what's called zeroed out to what I just cut, all right? So it's totally zeroed out. I can take the dial. Remember I showed you those dials? And I'm gonna put the dial on 0. Okay, so my dial is on 0. Check this out, all right? I'm going to take a measurement here without taking this out, all right? And what this is saying is 2.319. 2.319. 2 inches, 319 thousandths. I need to go to 250 thousandths. Alright? So, that's 50 thousandths and 19. I know it's hard to do online, on video. That's what it's saying. I know, and the glare on the dial and everything. I need to go, there's 0.3, and then there's 50. So I need to do 69 thousandths. I can't do 69 thousandths in one pass, all right? So what I'm gonna do is I got this zeroed out, and what I'll do is I'll probably take 4 passes. 3 at 20, and then 1 at 9, okay? So here we go. Let's do that. So 0, right? I gotta go to 69. So there's 20. Another 20. if everything went as planned, this block should be 2 at 0.250. And we can measure that, and it is. Okay, it's 2.25. Okay, so I can go ahead and I can take this out now. All right, and I'm gonna move I'll move the table off to the side here. Get this out. Okay. And file. All right. So, take a measurement. Okay, so 2.249 and 2.249, okay? And yeah, so we're looking pretty good, okay? All the way around. So I know now that I've got a pretty trued up block on 4 sides, okay? Now, we could machine these to be all 6 sides to be trued up. However, that's not necessary for our project, okay? I still might, I don't know yet. I'll decide in a moment. But what we need to do is we need to go over to the, we need to take a look at the print, okay? And now it's time to actually make our part. I'm gonna have to machine this down to, I'm gonna take a little bit off of here, off of one of these surfaces, okay? And we'll go ahead and we will machine our part. All right. Cool. All right. So here we are. We got our block trued up and to dimension. You can see that, okay? Except for the width. We're gonna need to, I don't know what this is right now, but it's looks like it's 925.925, 925 so we need to get it down to 3/4. I'm gonna I'm gonna do that with the end mill and when we put the slot in. So just so you can see what's, we're gonna put the slot in this neighborhood here. I'm not gonna measure, this is the area we're gonna be removing, right? We're gonna put this slot in. So I'll take this down and then we'll mill out this area, okay? But then, more importantly, I wanted to show you, these are our tapped holes. I went ahead and pulled the taps. This is a different style tap than what I showed you the other day. This is a spiral tip tap, also known as a gun tap, which I don't like to use that term, but it's a spiral tip tap, and it's great for tapping on the mill, which you're gonna see shortly, okay? Maybe I'll talk more about these particular taps later as we go. Real quick, here's the tap drill that here's a 1/4-20 to mount the indicator with a 1/4-20 socket head cap screw there, okay? And then we've got the 5/16 18 tap for this thumb screw, okay? And that goes down here, okay? Real quick, so if we go over to the tap drill chart, right? We can see here 5/16 18 we drill with a letter F. For 1/4-20 we drill with a number 7, all right? And that's exactly what I have here. So I've got a letter F drill bit, all right, to go with this 5/16 tap, and I got another number 7 drill bit to go with this 1/4-20 tap. So we're gonna go ahead and take all this over to the mill, and I'm gonna show you a couple other techniques.
I completely realize that this video is long, by the way, but these are the fundamentals that you really need to know. Put that down. All right. So I'm going to go ahead and with parallels, okay, I don't need that. Remember, I don't need the aluminum bar anymore because we're all trued up, okay? And I'm going to put my material in here. Oh, forgot one thing. All right, I forgot something. Sorry, guys. All right. So before I put my material in, I'm going to show you something. And so remember the numbers on the hand wheels, okay? I have another method of measuring. It's quite a bit more accurate, okay? And it is called a digital readout. Yeah, the digital readouts from the 80s, I know, and stuff. It looks like the space shuttle. All right. So you can see here that as I turn the wheel, I'm turning Y right now. I'm turning Y handle, that I'm getting how much I'm moving up here on the digital readout, all right? So we're gonna go ahead and use that. In order for me to, it's gonna be in like that. In order for me to come off 0.375, okay, right here, sorry, 0.375 right here, I'm gonna have the material in the vise like this, okay? So what I need to know is where the back of the vise is in relationship to the center of the spindle, all right? And that's exactly what I'm gonna do right now. And you guys, I know this is confusing at first, but we're gonna be doing this so many times, you'll get used to it, all right? And I'll probably even shoot a special video to go over it again. But just bear with me and watch this. What I have in the mill right now is like a drill chuck, basically, okay? I'm gonna use a tool called an edge finder, okay? And that's exactly what this does. This, you'll see, I'm gonna use it right now and explain what's going on. This finds the edge of, say, the back of the vise, all right? Now, one thing we have to know is that that this edge finder is 200 thousandths exactly, okay? So I'm gonna go ahead and put this in here, and I'm gonna run this about 1,000 RPM. You don't want to run it too slow, but you also don't want to run it too fast either. So and what I'm gonna do is I'm gonna find the back of the vise, the edge right here, okay? And I'm gonna make it exactly in the center of this spindle, okay? I gotta turn the mill on. And then I'm gonna use the DRO. I'll explain as I go. So, bring this down. And what I'm gonna do is bring this up kind of close, okay? Yeah, right about there is good. And I'm going to make this, what happens is this is spring loaded. And so it'll run concentric or non-concentric. So what I'm gonna do is I'm gonna run this non-concentric like this. I'm gonna turn on the mill. And you can see that it's wobbling around like crazy. And now I'm gonna move Y. And we're gonna start to see it's starting to turn concentric. Okay, now we're running really concentric, and I'm gonna turn Y really, really slow. And as soon as it kicks out, that right there, all right? I'm gonna zero the DRO. So Y, 0, all right? And now I'm gonna do it again. And I'm just gonna kick this out. See, now it's wobbling, okay? I'm gonna bring this in real slow. Okay, it's starting to run concentric, There, it just kicked out. And I'm 5/10 away, all right? So, okay? Now, okay. So, this was non-concentric, right? And then as I got it closer to the back of the vise, it ran concentric, and then the moment it kicked out on me, I stopped and I zeroed my DRO. So remember I said what was really important was this is 200 thousandths, okay? So I need to take half that diameter. Half the diameter, which is 100 thousandths. So now I'm gonna move Y 100 thousandths, which is half the diameter of the edge finder. Sure you can see that. Yeah. And there we are. 100. Well, I mean half a thousandths. Like it's not that important, especially for this part. Let's see if I can get it. I don't even think this. There we go. Okay. So I'm going to zero that out. All right. Now I know that the center of my spindle is perfectly aligned to this edge, okay? And I'm just gonna hang on to that zero the whole time. You'll see. Okay, so what I gotta do now is change tools. First of all, let's take this out. And I am going to use this 3/4 inch end mill. So we're going to use 2 parallels. And I am going to put that in there, okay, like this. Same technique as before, except I'm going to this out here a little bit. Let's see. Now, let me see here. Move this over a little. Something's going on in there. See what's going on. There we go. Now we're in. Yeah, we're in. Yeah, we're in. There we go. We're in. All right. So we're in. Okay. Now what I'm gonna bring this up closer to the tool so you can see. All right. So, right now, the center, I think you can see that, the center of my end mill is directly in line with this edge, all right? And if we look at the print, we know that we need to move it over we want that to be 0.375. But, shoot. First, I got to bring this down to the right dimension, which is 0.75. Okay, so check this. I'm just gonna do that, and you'll see that. Okay, I know. All right. I'm gonna run that about 1,000, and let's raise the table up a little. And all right, so I touched off, and I'm gonna give this about, I don't know, well, about 25 thousandths. Yeah, that's a good speed. Okay. And maybe a little faster. Yeah, that's good. And I'm just gonna work my way around, all right? All right. So, now I'm not gonna move, I'm not gonna take my part out or move anything. What I'm gonna do is the same kind of trick that I showed you before. I'm gonna take a measurement here. All right. And, all right, let's see what we got. We've got 75. So we've got 0.875. We need to go to 0.75. So we need to do, there's 25, there's 50, and another 50 to 0.75. We need to do 125 thousandths. I'm gonna put my Z on 0, okay? And I don't wanna do it all in one pass. With an end mill, I can take quite a bigger cut, like depth of cut, especially with a bigger end mill, like that 3/4. So I'm gonna go ahead and do 50, all right? So I'm gonna raise the table 50 thousandths. All right, I'm gonna go ahead and turn the machine on. And, all right, so there's 50 thousandths. And we'll just snake our way around. All right, now we'll do another 50 thousandths. So that'll take us to 100. I engaged Y. All right, so according to the dials and my measurements, I should have 25 thousandths to go. Let's see, and I do, there's 25 exactly. So I'm gonna go ahead and take 25 thousandths. And this will be it. Okay, so we can check it. Let's see. Come on. Can't get the... Let's see. Get the calipers in there. Yeah. 0.75 on the money. All right. So, now, I'm going to zero my Z, okay? Because remember, I just cut this, right? So I know that the bottom of the tool and the top are zeroed out. So now I've got my Z on 0. I found the back of the vise already before we started. Okay, so let's bring this around. And if I put Y on 0, okay, right there, then remember, now I know, let me blow this out so you can see better. The air's off. Okay. The center of the tool, the center of the spindle and the tool is on this edge. The diameter of this end mill is 3/4 of an inch. So if I move Y half of the diameter of 3/4, which is 0.375, the edge of my tool now is exactly at the edge of the vise or the back of the part. I need to move over now because see, now there's the edge, right? I want to move over another 0.375. Okay, so I move over another 0.375, which will be 3/4, coincidentally. Come on, Blake. All right, there we go. So there's 0.75. What I'm gonna do now is I'm gonna zero this. That's where I have to stop. All right? And now if we look here, I wanna go 1.95 inches this way. But I have the diameter of the tool to consider. So, what I need to do is take 1.95 and subtract the diameter of the tool. That's the diameter of the tool, 0, 0, 2, 1. So I'm gonna be moving Y 1.2, okay? And I'm gonna be doing a depth of 0.5 inches. See the depth right here is 0.5 inches deep, all right? So my first pass, I'm gonna take, I'm gonna do an 1/8, okay? So I'm gonna go a whole 1/8 of an inch deep. So there's an 1/8 of an inch deep. All right. And I'm gonna save 5/1000 off the back and 5/1000 off the front. I know, just bear with me, you guys. It'll all make sense the more we do it, okay? And that'll be, I'll come back and clean everything up, all right? So I'm gonna go ahead and move this. Say 20/1000 is fine. I moved it 20/1000, okay? Yeah, that's fine. So I'm gonna go ahead and turn this on. And I'm gonna see how we're doing here. Pretty good. So I'm gonna go ahead and engage the power feed. And I'm gonna come all the way off the part. Okay, now I'm gonna do, just watching this, I'm just gonna come over about there. Doesn't really matter. Take another pass. So I'll take this about to there. I think that'll do good. Whoops. All right, so this pass, I want to leave a little bit before I go clean it up, right? So I'm going to do 1.18 on the DRO. 1.18 or 7.5, something around there. Good enough. Go ahead and take another 1/8 on the depth. go back to 0.025. Whoa, wrong way. 0.25, right there, that's good enough. Come back. Looking good. All right, another 8. So now we've gone 3/8 deep. 3/8, and we need to do what? A half. Okay, now I'm just gonna go ahead and finish it off. So one more 8. There's an 1/8 deep. All right, I'm gonna move this to 1.2. There we are. And let's finish it off. All right, so now I'm finishing it off, so I'm gonna take it to 0. Okay, so I'm gonna bring the part out here. I'll bring the part out here, and with a rag, wipe some of these chips away. Okay, and I want the depth to be perfect, but the depth isn't that important. Remember, what's important is that slot width. So that's, I'm gonna measure, go ahead and measure that. And I said, oh, that's good. 1.47. Whew. So we're in tolerance, okay? What I'm gonna do, that'll work. So what I'm gonna do now is I'm gonna take this out and let's go see if it fits. All right, so that's what we did. I got some deburring to do. Right, we'll just use a file here. And really lightly. Got a little, hit this corner here. And this corner. All right, let's go see if it fits. I hope it does. Yeah. So it fits on there nicely. It slides very freely. Okay. All right, so that's great. Sweet. All right, sweet. Now what we got to do is we got to drill and tap some holes up here. All right, so take these out for the time being. Now unfortunately the air's off, so no problem. Just have to clean this out really well with a rag. Yeah, you'll notice that the table can get messy, but around the vise, I keep it pretty clean. those chips, man, they'll ruin your project in a second. All right. So we want this here. I'm not going to use a parallel, but I got to get rid of these burrs down here. Okay, it's pretty good. All right, yeah. So we'll go ahead and put this in. I'm not going to use a parallel, even though I probably should. And it's all right. It's not as rigid as I'd like it to be. I probably should have. Nah, never mind. I won't even say that. All right. Okay. Take out this end mill. We'll go ahead and put the drill chuck back in. Lower the table a little, and I'm gonna show you real quick here. Now, the way that this is dimensioned is right here. You can see that. Okay, so off of this edge, this hole's 0.5 over. And this hole's 1.625 over. And then off of this face right here, or edge, this hole's 0.25 and this hole's 0.3. All right, so really what I'm after, if you think about it, is I want to find this corner, right? So I want this edge and this edge. And I'm gonna use the edge finder again, okay? So let's get that up close. Let's see. Whoop. All right. And okay. Let's do it this way. Okay, so I want that edge, right? So I'll go ahead and turn this on. Make that not concentric. See how it's all wobbly like that? All right, now I'm moving X over really slow. There, it's starting to go concentric. It's pretty concentric. And I'm going real slow. There, it just kicked out, okay? So I'll go over and I'll 0X. And now I'm gonna do it again. Just kicked out, and look, I'm right at 0. That's great. So I know that I'm at 0. All right. Let's do Y. Okay? Kick it out. Approaching, start concentric almost. Concentric. Kicked out. Y. 0. Let's do it again. Kicked out. Look at that, Y0. So I'm pretty spot on. All right. So I can go ahead and take that out. And remember now, this is 200 thousandths, okay? So in order to get it to center, all right, I need to move my X and my Y 100 thousandths. Okay, so I'm gonna go ahead and do that. So there's 100 on Y. Oops. All right, and then come around to X and put that on 100, because remember we zeroed it out. All right, if I hit X, Y, 0, I'm right at this corner. Okay, I'll explain this tool a little bit later, but this is called a center drill. And I'm gonna put this in here. And if I lower this down, you can see that it's right, the tip is right at the corner. Okay, so now we just use our Cartesian coordinates. It's that easy. We'll move Y 0.25, right? 0.25. Y 0.25. And then X 0.5. All right, don't worry about the 10 thousandths place on this particular part. You guys, that's what's that? That's a sixth of a hair, like a 1/6 of a diameter of a hair. Okay, so what we got here is a 5/16 18. So I'm going to center drill like that. Okay, take this out, and now I'm going to use the letter F. Let me lower the table so I can get the drill bit in there. Okay, so here's the letter F drill. It even says on there, F. Put that in. Okay. Go ahead and we're going to drill all the way through. All right. And now we'll take our 5/16 tap. And this is the part that I said I'll say all the time. You know, there's time when, so I would never show you this in class, okay, in the regular lab. But I'm just trying to show you, especially in the beginning here, just what it's like on the floor, okay? As we go, we'll get into more details. I'm gonna power tap. And the reason that I'm getting away with this is WD-40, by the way. The reason I'm getting away with this mostly is because it's a through hole. And I have a spiral tip tap. So I'm gonna turn this on, turn it off, let it slow down a little, and now, whoop, put it in. I'm talking, I meant to put it in reverse. Hang on. That's what happens when you're talking. I meant to put it in reverse. So we'll just back this out with a tap handle. Alright. So now we've got threads. I almost blew that. Okay. If it wasn't for my cat-like reflexes. Okay, so let's go move on to the next hole. That is the 1/4 20 hole, and that's 0.3. So let's move the DRO or I should say the table, to 0.3. All right, and then we'll move 1.625 over. I know you can't see that very well. I know. Come on, 1.625. Too far. And close enough. There we go. We're on. Okay, so center drill. We're gonna drill with our number 7. So that's our tap drill. Okay. Put our 1/4-20 tap in and do it again. Get some WD-40 in there as a lube. Maybe this time I'll actually be successful. Yeah, it's stuck on me, no problem. So we just pull that out like that. Take our tap handle and finish these threads. By hand. So I'm giving it like a turn or a turn and a half, and then I back it off to break the chip. See the chips falling out the bottom. I don't know if you're paying attention. When I break the chip, you can see them. They fall out the bottom there. It's pretty tight, actually. It'll be all right. Okay. So we'll back this out. Okay. All right. That's it. So I'll turn this off. And now, before I assemble our tool, I'm gonna do a little bit of cleanup. Okay. And what I'm gonna do first is I'm gonna go over to the drill press, and I'm going to countersink these holes. So here we are at the drill press. I'm just gonna put this in here like that. And believe it or not, I'm gonna do a little technique here that I do often. It kind of line it up a little, and then I self-center. It'll self-center itself. So just that's it. That's all we need to do. Okay. And I'll move this over here. You guys, you're gonna see this so much that I'm not. Just watch. Okay. I'd love to countersink that side, but that's impossible. Well, nothing's impossible, but I can't do that right now. Now I'm gonna take a, actually, let's go over here. And I'm gonna take a 3-corner file, and one of these corners on this 3-corner file, they actually cut. So what I do is I grind one of the corners off so it doesn't cut. And what I'm able to do now is come in here and deburr this without ruining my part. We can see that that fits pretty good, and goes all the way through. Okay, and I'll check the other one in a second. I'm trying to hurry to keep the video time down, because I know you guys don't like them long. I'm gonna switch files, but I'll bring the parts with me. Okay. I see something here. I think it's, no, it was that one. Yeah. Okay. And this here. Grab there. Another file that I ground the edge off of. Come in here and just knock those burrs off of this. Okay. And especially off the inside, these inside corners. Hit this one more time. Bottom of those holes. I can feel that made pretty good contact there. Just hit this real quick. This corner. Oh, it feels pretty good. All right, let's just make sure it fits. It does. Now we can go ahead and see if this fits. Looks like it's going to. So we'll pop this screw in here like that. All right. Tighten it up. Hope you tighten it up. And so that's on there. It's not moving. That's pretty cool. Okay. We're getting somewhere here. All right. So we'll go ahead and start this. Okay. And let's go over to the lathe that it goes on. Put this here so you guys can see. And then, so that slides on there real nice. And now this thumb screw locks it into place, right? Now it won't move anymore. And hopefully, yes, we made it. There we are. It's working. Okay. So then I can zero this out. Okay. Looks pretty good. And then it will slide out of the way. Not great? All right. So right on, you guys. We just made our first. Not only did we make a cool part, we made a tool. Awesome. Okay. See ya.